Hello, my name is Tom, and today we'll be learning about toolkit functions and transformations. More specifically, there are multiple kinds of toolkit functions, but more specifically we're going to be learning about ln of x, or natural log of x, it's also known as. All toolkit functions have characteristics, as in domain, range. The domain are the x values, the range is the y values, the x-intercept where it crosses the x-axis, or the line cuts through the x-axis, or the y-intercept where it cuts through the y-axis. Whether or not it's an increasing function, you read it from left to right to decide whether it's increasing or if it's decreasing, whether or not. Concavity, if it has a curve, then is the curve pointing down or is it pointing up, if it curves up or curves down. And asymptotes. Asymptotes are whether or not it'll ever cross an axis. Like, if it never crosses the y-axis, then its asymptote is the y-axis. If it never crosses the x-axis, and its asymptote is the x-axis. To figure out the natural log of x, you go to your calculator, and you go to y equals, and clear everything out right here. And you press, there's an ln key, a natural log key, press that, and then go to the x key and press x and close parentheses, and then you press the graph key, and it'll bring up a picture of the graph itself. It'll bring up a picture. The picture quality is not going to be that good because it is a calculator, but the line will never touch the y-axis. Just draw that out here for you. Yeah, actually did. I was able to follow. And it never really touches the y-axis, but we'll get into that in a second. Now for the characteristics. As far as domain, which is the x values, it never touches the y-axis, so you know it has to be greater than 0. It'll keep getting closer and closer and closer, but it'll never actually touch. So x values have to be greater than 0. It can be anything greater than 0, because as you can see, the line just keeps running on. So x is greater than 0. As far as the range is the y, all the y values, and y can be any real number, because as you can see, it'll go on forever. It'll go on forever this way, and it'll go on forever that way. So you know it can be any real number. Y. X-intercept is where it crosses the x-axis, and that is 0, 1, as you can see right here. The y-intercept, it will never cross the y-axis, so that means there is no y-intercept, so you're just putting on. Is the line or toolkit function increasing or decreasing? As you can see, it never, or if you read it from left to right, so as you can see, if you read from left to right, it's going up, so it would be increasing, but yes. But it's not so that means it can't be decreasing, because obviously it's increasing, so it can't be decreasing. Just put no. Concave up or concave down, which way does the curve really point? And the curve kind of points on an angle, but it's pointing down. So you know that concavity would be down. And an asymptote, where it'll never touch the y-axis. So your answer for asymptotes would be the y-axis. Be specific. You can't just say yes or no. You have to be specific and say, yes, it is the y-axis, or yes, it is the x-axis. And this is the graph, which you can pull up. It'll tell you the exact points for plotting. You can pull that up through second, and then the graph button right here all the way to the left. You press that, and it'll give you a list of all the plots and points. The inverse function to the natural log of x is y is equal to e to the x power. To get that, you simply press y equals, clear that out from your previous function, y equals, and you can press the second natural log button, same one you press for the natural log of x, just second, and then you can press the x button and it'll give it for you. Press graph and it'll pull it up. And it looks sort of like this. Come down like this and you just go up. It'll never really touch the x-axis like that. It's kind of steeper, but still. And you can figure all that out on your calculator.
I just wrote down
Seth Penny, please come to the front office. Seth Penny, please come to the front office.
Transformations. A transformation is changing the natural line or toolkit function. As you can see, this is the natural toolkit function, ln of x. It just comes up, and this is the normal one. In order to change a toolkit function, you have to add or subtract or multiply things. And if I wanted to flip this vertically, or flip it up, I can put a negative sign in front of the natural log sign, like so. In order to do that, you just press y equals, clear it out. You press the negative sign down here, and then ln of x in close parentheses. And you click graph, and it'll bring it up, and it's just like it flipped it vertically, like over the x-axis, almost. It doesn't specifically flip it over the x-axis because it's not a reflection, but it'll come down. Oh, let me use a different color. Use blue so then it color coordinates. It'll come down like that.
Yeah, that's what
Just like that. It's like you just took it and just flipped it vertically. You put a negative sign in front of the ln. If you want to flip it horizontally, you have to put a negative sign in front of the x and make sure you close the parentheses and be specific, or else your calculator won't be able to figure it out. So you just do the same thing, just put a negative sign in front of the x and close your parentheses, and it'll pull it up for you. And it'll look a little something like this. Just like that, just like you flipped it right over. If you want to move it, say you just want to take the regular function and just move it up, like 5 places. Make sure you close the parentheses and you move it up. It'll move it up 5. If you add, it'll move it up, subtract, it'll move it down like that. Say we added 5. You put it into your calculator, ln of x, close parentheses, plus 5. And it'll take the whole line and just shift it up 5 so it'll look something like this. It'll just come up and just shift it up 5. Just like that, it'll come up. And then you do the exact same opposite. If you want to move it down, you just subtract 5 from the function. Use that same color. And it'll move it down here by like 5. It'll make it a negative. Like that. I don't really moving it left or right. I didn't write any examples down, but I'll show you that. Say you wanted to move it left 5. Say you got the normal function like this, and you want to move it over to the left 5. You put ln of x, and say I want to move it to the left, I would add 5 and then close parentheses in order to move it to the left. And if you want to move it to the right, you do ln x minus 5. So it's kind of like the opposite. If you add 5, it'll move it to the left, or if you subtract 5, it'll move it to the right. And the graph would look just like this. 2, 4, 5, we'll say it's right here. And that'll be that one. And then say you want to move it to the right, it'd look just like that. Like that. Pretty simple. And that is the natural log of x and 2 functions. And that'll be it.